Right, question 9, coordinate geometry. Lovely. The points A and B have coordinates this and this respectively. Given that A and B is the diameter of the circle, show that the centre has coordinates 3, 6. If in doubt, draw a sketch. If you know what to do for 1 mark, and just do it. If you're ever in doubt, do a little sketch. I'm going to do one anyway. Lovely. Minus 2, 11. That is point A. And 8, 1. That is point B. There. AB is the diameter of a circle. So the circle, check out the colours, looks like this. Whee. Yay. We have to show that the centre has coordinates 3, 6. You should be able to see that all this question is asking you to do is find the midpoint of these two. Midpoint is just when you add the coordinates together and half them. x1 plus x2, I'll write this. Midpoint of AB, you don't have to write this formula down if you know it, but it's to get the x coordinate, you do the x1 plus the x2 and half them. To get the y coordinate, you add them together and half them. So you end up getting minus 2 add 8. Oops. Minus 2 add 8, halving it. And 11 add 1 and halving it. So you end up with 6 over 2 is 3 and 12 over 2 is 6. And that will get you the 1 mark. Even if you just write this bit here, that'll get you the 1 mark there. Find the equation for C. Remember, C is the equation of the circle. So a bit like when I'm asked to find the equation of a straight line, I write y equals mx plus c. When I'm asked to find the equation of a circle, I write first the general form of the circle, which is x minus a all squared plus y minus b all squared equals r squared. A and b are the coordinates of the centre, which we know already, thank you. And r is the radius, which we'll have to do some work for, and that's why it's 4 marks. So we know that a is this one, and b is this one, because that's the centre of the circle. We need to find the radius. Well, the radius is this distance, so the distance between 2 points. You could find the distance of the diameter and half it. I'm going to, though, find the distance between the centre and this point here, the radius, straight away, because I can't be bothered to half it at the end, and it means I'm going to just deal with whole numbers, which I like. So for part B, the radius equals, it's just Pythagoras to get the distance between 2 points. It's the difference between the x's squared. So 8 minus 3 is 5. So that's 5 squared plus difference between the y coordinates. 6 minus 1 or 1 minus 6. That's 5 squared is 25. So r is the square root of 25 plus 25, which is 50. So root 50. Because we need r squared, then r squared is just going to be 50. So the final equation of the circle, x minus 3 squared plus y minus 6 squared equals 50. And that there will highlight it to make it a bit clearer for you. Ooh, green. That is your final answer. That was the final answer for part A. This is the final answer for part B. You do not go and try and multiply this out. That is the general form of the equation of the circle. Next part, part C. Verify that the point 10, 7 lies on C. So verify that this coordinate lies on there. 10, 7. If we go on the next page, I've already copied it there. So we've got the point 10, 7. X, y, so we need to substitute that in and hopefully it will work and equal 50. So x is 10, so 10, this is for part C, 10 minus 3 all squared plus y minus 6 all squared equals 7 squared. Oops, y is 7 plus 1 squared equals 49. What is going on? Plus 1, which equals 50, which is what it says there. So that point works there, so we've done it. That's part C. Then we have to find an equation of the tangent to C at this point, given your answer in the form y equals mx plus c, where m and c are constants. They don't have to be whole numbers, just constants. So we need an equation of the tangent to C at the point 10, 7, which is probably going to be somewhere along there, given your answer in the form there. So I have drawn out this diagram here in a bit of a nicer way, over here somewhere. There, draw it out again. So when we have to find the equation of the tangent here at that point. The pen. Let's have a green straight line. Problem. There. Put the rubbish there. See if we can move it a bit. Yay. It's not quite right, never mind. The tangent, see, I still can't stop at fiddle. There. We have to find the equation of that bit. That's a straight line, so for part, I can't remember which part it was now, D. So for part D, it's a tangent, so it's equation of a straight line. We need the gradient first, and then it's really easy to find C. You just pop in a point that lies on the line, and we know the 10, 7 lies on the line. So getting C will be easy, but we need to get the gradient first. The gradient of this point, we don't know 2 points that lie on it, so there's no point trying to do y2 minus y1 over x2 minus x1 for this line. However, you need to know the property that if you have a radius and then the tangent to that radius is always 90 degrees, despite from my sketch it not looking exactly 90, it's not bad. So this green line here, if we can find the gradient of that, which we can easily because we know 2 points, then we will just find the perpendicular of it. So we'll stick with green. The gradient of the radius that's in green is y2 minus y1 over x2 minus x1. So that's 7 minus 6 all over 10 minus 3, which equals 1 over 7. That's the gradient of that green line. Therefore, to find this one, it's perpendicular. So therefore, gradient of tangent, and remember it's 1 over it. So if it's a fraction, you just flip it and you change the sign, which is just -7. So the gradient of that line there is -7. Y equals -7 x plus c. And now for the last little bit, we can find c because we know a point that lies on this tangent. Remember, this here is now the equation of this tangent, and the only point we know that lies on it is 10 and 7. So 7 equals -7 times 10 plus c. 7 equals -70 plus c, so c equals 77. Final bit, let's do it here. Therefore, equation of tangent is y equals m was -7 plus 77. And if you remember, the question didn't ask for it in ax plus b or anything like that. It wanted it in y equals mx plus c form. Just go back, quickly check that we've done it. Find an equation of the tangent of C at the point 10, 7, given your answer in the form y equals mx plus c, where m and c are constants. Brilliant.